Question 8, Part A. A particle is moving in a straight line. Its displacement, x meters from the origin O at time t seconds, where t is greater than or equal to 0, is given by x equals 1 minus 7 over t plus 4. Part 1. Find the initial displacement of the particle. Let t equal 0 in the displacement equation to find the initial displacement. So x of 0 is equal to 1 minus 7 over 0 plus 4, which equals 1 minus 7 over 4, which equals negative 3 over 4. Therefore, the initial displacement of the particle is negative 3 over 4 meters, or 0.75 meters in decimal to the left of the origin. Part 2. Find the velocity of the particle as it passes through the origin. Before we find the velocity of the particle, we need to find the time when the particle passes through the origin, and that is found by solving the displacement equation x of t equals 0, since the origin represents a displacement of 0. So we need to solve for t the equation 1 minus 7 over t plus 4 equals 0. This implies that 7 over t plus 4 must equal 1, since 1 minus 1 equals 0. So rearranging the equation, we get 7 over t plus 4 equals 1. This implies that the denominator must equal 7, since 7 over 7 equals 1. So rearranging the equation again, we get t plus 4 equals 7, hence t is equal to 3. Now the velocity of the particle is given by dx dt, where x is equal to 1 minus 7 over t plus 4. So before we differentiate x with respect to t, rewrite the displacement equation using negative indices. So x is equal to 1 minus 7 times t plus 4 in brackets to the power of negative 1. Differentiating x with respect to t, we get dx dt is equal to negative 1 times negative 7 times t plus 4 in brackets to the power of negative 2. And expressing dx dt using positive indices, that equals 7 over t plus 4 in brackets to the power of 2. At time t equals 3, the velocity is 7 over 3 plus 4 in brackets to the power of 2, which equals 7 over 49, which simplifies to 1 over 7. Therefore, the particle passes through the origin at 1 over 7 meters per second. Part 3. Show that the acceleration of the particle is always negative. The acceleration equation of the particle is given by the second derivative of the displacement equation, d squared x over dt squared, which is equal to the derivative with respect to t of the velocity dx dt, where dx dt is equal to 7 over t plus 4 in brackets to the power of negative 2, which we found in part 2, and that's equal to 7 times t plus 4 in brackets to the power of negative 2 when expressed using negative indices. Hence, the acceleration d squared x over dt squared is equal to the derivative of 7 times t plus 4 in brackets to the power of negative 2, and that equals negative 2 times 7 times t plus 4 in brackets to the power of negative 3, which equals negative 14 over t plus 4 in brackets to the power of 3 when expressed using positive indices. Now, the denominator, t plus 4 in brackets to the power of 3, is greater than 0 for t greater than or equal to 0, and the numerator is negative. Now, dividing a negative by a positive will yield a negative. Therefore, the acceleration of the particle is always negative. Part 4. Sketch the graph of the displacement of the particle as a function of time. The graph of x equals 1 minus 7 over t plus 4 is the graph of the base curve x equals 1 over t that has been dilated vertically by a factor of 7, reflected in the t-axis because of the negative here, and then translated vertically up by 1 unit. Horizontally, the graph is shifted to the left by 4 units. That means the asymptotes have also shifted accordingly. So the horizontal asymptote is now at x equals 1, and the vertical asymptote is now at t equals negative 4. But the graph is defined for values of t greater than or equal to 0. Here is a sketch of the graph x equals 1 minus 7 over t plus 4. Notice that the graph is only drawn from the vertical axis to the right. Now initially the displacement is negative 3 over 4, and that's shown here. And the particle reaches the origin at time t equals 3, and that's shown as the t-intercept here. Notice that the graph is not defined for negative values of t, hence this part of the graph is left blank.